divisibility rules. Here, if I take a number m when divided by n, if the remainder is 0, m is divisible by n. For example, if I take a number 624 divided by 8, if the remainder is 0, that means 624 is divisible by 8. Now we are going to discuss the divisibility rule for the numbers. That the divisibility rule for 2 is very easy. The last digit should be divisible by 2, or we can say all the even numbers are divisible by 2. The divisibility rule for 4 is last two digits of the number should be divisible by 4. For example, if I take 156720, it's a big value. Here we need to check whether it is divisible by 4 or not. Just look at the last two digits. Last two digits are 20. That's a 20 is divisible by 4. So that means the total, the number is divisible by 4. The divisibility rule for 8, that's nothing but last three digits will by 8. 1563624. If I take this number, last digit is 624. 624 when divided by 8, the remainder is 0. That means the total number is divisible by 8. We understood the divisibility rule for 2, divisibility rule for 4, and divisibility rule for 8, divisibility rule for 16. Now you can understand last 4 digits should be divisible by 16. From this one thing you can understand the similarity. The divisibility rule for 2, divisibility rule for 4, divisibility rule for 8, divisibility rule for 16. If the divisibility rule for 2, that is 2 means 2 power 1. The divisibility rule for 2 is last digit be divisible by 2. 2 power 2, last 2 digits will be divisible by 4. 2 power 3 means last 3 digits should be divisible by 8. 2 power 4 means last 4 digits should be divisible by 16. 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16. If the power is 1, 2 power is 1, last digit. 2 power 2, last 2 digits divisible by 4. 2 power 3, last 3 digits should be divisible by 8. 2 power 4, last 4 digits divisible by 16. If I ask you 2 power 5 also, you can find out the rule. Even if I ask you 2 power n, last n digits divisible by 2 power n. That's very simple. What's the divisibility rule for 2 power n? That's nothing but last n digits should be divisible by 2 power n. Have you understood the divisibility rule for 2, 4, 8 and 16? The divisibility rule for 5. It's very easy. Last digit is either 0 or 5. If a number ends in 0 or ends in 5, it is divisible by 5. 12540. Is it divisible by 5? Yes. Next 1395. Is it divisible by 5? Yes. Divisibility rule for 9. It's very important. You have to know the divisibility rule for 9. The two methods. The first one, the divisibility rule for 9. Sum of the digits should be divisible by 9. Why sum of the digits should be divisible by 9? That I'll explain you with example. If I take multiples of 9, the first one 18, 27, 36, 45, 54 ... Sum of the digits 1 plus 8 9, 2 plus 7 9, 3 plus 6 9, 4 plus 5 is 9 and 5 plus 4 is 9. Here if the sum of the digits of a number is 9, that is divisible by 9, or we can say the number is divisible by 9 means the sum of the digit is 9. If I take one example 58743, is it divisible by 9? Yes. Check it. 5 plus 8 plus 7 plus 4 plus 3, 5 plus 8 13 plus 7 20, 24, 27. Here sum of the digit is 27. Again add these two digits, 2 plus 7 9. This is divisible by 9. That's very simple example. Why we need to add sum of the digits? That is very important. Now I am going to explain. Here first take 10 divided by 9, the remainder is 1. 100 divided by 9, remainder 1. Next 1000 divided by 9, the remainder is 1. 10,000 divided by 9, the remainder is 1. From this we can understand one thing, why we need to add sum of the digits for the divisibility rule for 9. Take one example 5823. If I take 5823, this can be written as 5000 plus 800 plus 20 plus 3. 1000 divided by 9, the remainder is 1. That means 5000 divided by 9, the remainder is 5. 100 divided by 9, the remainder is 1. Means 800 divided by 9, the remainder is 8. 20 divided by 9, the remainder is 2. 3 divided by 9, the remainder is 3 itself. So 5 plus 8 plus 2 plus 3, 18. Here 18 is divisible by 9. So this number is divisible by 9. Have you understood why we need to add? Here all the cases the remainder is 1 1 1 1 3 6 1a. The condition is given, this value is divisible by 9. Can you find out the a value? It's very simple. 3 plus 6 plus 1 plus a. 3 plus 6 9, 9 plus 1 10, 10 plus a, 1 plus 0 1, 1 plus a. It is given, this value is divisible by 9. A is 8. I'll explain you how to find out the sum of the digits easily. If I give you a number 72186354 is it divisible by 9 or not? It's a very easy. Before solving, just look at the number 72186354 72 sum of the digits 9, 18 sum of the digits 9, 63 sum of the digits 9, 54 sum of the digits 9. Here the remainder is 8. Even if I arrange in this order, if I write 7 4 8 6 2 5 3 8, I rearranged 7 and 2 9, leave it. Next 4 and 5 9 and 6 and 3 9. Then I missed one number here, 1 and 8 9. So the left out is 8. Even if you rearrange also, there is no change in the sum. Divisibility rule for 9, instead of saying sum of the digits should be divisible by 9, we can say sum of the digits would be 9. That's very simple. While adding the digits of a number, if it gives 9, then that number is divisible by 9. If I take a number 15 divided by 9, what's the remainder? Don't try to find out the remainder, just add the digits, that's enough. Sum of the digits is the remainder when divided by 9. One more example I'll give you. If I write 143 divided by 9, what's the remainder? 1 plus 4 5, 5 plus 3 8. The sum of the digits 8, the remainder when divided by 9 also 8. If I write 153 divided by 9, 1 plus 5 is 6, 6 plus 3 is 9, 9 divided by 9, the remainder is 0. Once the sum of the digits is 9, then it is divisible by 9. To find the remainder when divided by 9, I am going to tell you the easiest way. If it is given 1 5 4 8 6 3 5, we need to find out the sum of the digits. Before finding the sum of the digits, cancel, which gives you sum of the digits 9. 1 plus 8 is 9, then 5 plus 4 is 9, 6 plus 3 is 9. Here the remainder is 5 and sum of the digits also 5. That I'll explain you. If I take 15 divided by 9, the remainder is 6. What's the remainder? 150 divided by 9, that also the remainder is 6. Here if I take 105 divided by 9, the remainder is 6. Just finding the remainder is nothing but sum of the digits. If I take 15 sum of the digit 6. If I take 915, what's the sum? 9 plus 1 10, 10 plus 5 15. 15, again add these two digits, 1 plus 5, it gives you 6. Next, instead of 9, I can write 7215. What's the sum of the digits? Sum of the digits, I'll say 6. Cancel 7 and 2. 7 plus 2 is 9. Even if you add 9 to the number or not, there is no change in the sum of the digits. For example, 817215. 1 plus 8 is 9, 9 plus 9 18, 18 plus 1 19, 19 plus 5 24, 24, 2 plus 4, again the sum of the digits 6. Here if the number is like this, just cancel 8 and 1, 7 and 2. Find out the sum of the digits for the rest of the digits. Then that's very easy to find out the remainder when divided by 9. The divisibility rule for 3 is very simple. Sum of the digits should be divisible by 3. Here if you compare the divisibility rule for 9 and divisibility rule for 3, there should be a similarity. In the divisibility rule for 9, sum of the digits should be divisible by 9. The divisibility rule for 3, sum of the digits should be divisible by 3. Why these two are same rule? I'll give you one explanation. Here the remainder, when 10 divided by 3, the remainder is 1. Next, take 100 divided by 3, the remainder is 1. 1000 divided by 3, the remainder is 1. 10,000 divided by 3, the remainder is 1. For example, 1, 2, 1, 2. We need to check whether it is divisible by 3 or not. 1212. 1212 can be written as 1000 plus 200 plus 10 plus 2. What's 1000 divided by 3? The remainder is 1. 200. 100 divided by 3, remainder is 1. 200 divided by 3, the remainder is 2. 10 divided by 3, remainder is 1. 2 divided by 3, the remainder is 2. The sum of the digits is 6. It is divisible by 3. That's very simple. Have you understood why we need to add sum of the digits here? That's nothing but 10 divided by 3, remainder is 1. 100 divided by 3, 1000 divided by 3, 10,000 divided by 3. Always it gives the remainder 1. That's why we are adding 1000, 100, 10 and 2. Divisibility rule for 11. The divisibility rule for 11 is totally different from the others. Sum of the digits at odd places minus sum of the digits at even places is equal to 0 or divisible by 11. Sum of the digits at odd places minus sum of the digits at even places equal to 0 or divisible by 11. Here please try to understand, it is not sum of the digits of odd numbers and sum of the digits of even number. That is, it's a very wrong approach. For example, 9952468. If I take this example, sum of the odd places, I'll tell you which are the numbers odd places. 8, 4 and 5. These three are at odd places. 6, 2 and 9. These are at even places. Odd places sum 8 plus 4 plus 5. Sum of the odd places minus even places 6 plus 2 plus 9. Here 8 plus 4 plus 5, sum of the digits is 17. 6 plus 2 plus 9, sum of the digit is 17. If you subtract, value is 0. So it is divisible by 11. Why here? There's a totally different logic behind the 11 that I'll explain you now. We take 10 divided by 11, the remainder is 10 or minus 1. Next, 100 divided by 11, the remainder is 1. 1000 divided by 11, the remainder is 10 or minus 1. 10,000 divided by 11, the remainder is 1. From this you can understand 10 divided by 11, the remainder is minus 1. 100 divided by 11, the remainder is plus 1. 1000 divided by 11, the remainder is minus 1. 10,000 divided by 11, the remainder is plus 1. So minus 1 plus 1 minus 1 plus 1 like this. Now I'll take this example, 58,278. 58,000 can be written as 50,000 plus 8,000 plus 200 plus 70 plus 8. One thing we know, 10,000 divided by 11 plus 1. That means 50,000 divided by 11, the remainder should be plus 5. 8,000 divided by 11. Here 1000 divided by 11, the remainder is minus 1. That means 8,000 divided by 11, the remainder should be minus 8. Next, 200. 100 divided by 11, the remainder is 1. That means 200 divided by 11, the remainder is 2. Next, 70. 10 divided by 11, that means 70 divided by 11, the remainder is minus 7. Next, 8 divided by 11 plus 8. From this you can understand 5 minus 8 plus 2 minus 7 plus 8. Sum of the digit odd places. Here we understood plus minus plus minus plus. So that's why we are adding sum of the digit odd places. 5 plus 2 10, 10 plus 5 15. Then minus symbol, 8 plus 7 minus 15. So the remainder is 0. That means this value is divisible by 11. Have you understood? While discussing the divisibility rule for 9, 10 divided by 9 remainder is 1, 100 divided by 9 remainder is 1, 1000 divided by 9 remainder is 1. But in this case, 10 divided by 11 minus 1, 100 divided by 11 plus 1. Divisibility rule for 7. For example, if it is given A, B, C, D, E, F. It's very simple. The divisibility rule for 11, we subtracted the digits at the odd places from the digits at the even places. Here, take last 3 digits, next 3 digits. Put the last 3 digits plus, the next 3 digits minus, the next 3 digits plus, next 3 digits minus. That means DEF minus ABC. If DEF minus ABC divisible by 7 means the whole number divisible by 7. I'll give you one example. Take this number 106659, just 6 number. Put plus for last 3 digits and put minus for next 3 digits. 659 minus 106. 659 minus 106. 553 divisible by 7. So that means this value 106659 should be divisible by 7. If it is 4 digit number, for example 1848, here we have only 4 digits. We discussed 3 digits. So put 2 zeros here. Put for these 3 digits plus, for the digits minus. 848 minus 001, it is the value 847 is divisible by 7. So 1848 is divisible by 7. Easy example I'll give you. Definitely everyone can find out the answer. 444 or 333. Is it divisible by 7? First one, take these 3 digits, put plus, these 3 digits minus. 444 minus 444, anyway 0. That means it is divisible by 7. 333, put plus here, 333 minus. If you subtract 333 minus 333, the remainder is 0. That means it is divisible by 7. It's a very simple one. Why this is differ from the other divisibility roots, I'll explain you. 1000 by 7, the remainder is minus 1. Next, 10 power 6 divided by 7, the remainder is plus 1. 10 power 9 divided by 7, the remainder is minus 1. 10 power 12 divided by 7, the remainder is plus 1. From this you can understand why we have taken the divisibility rule 11. Next digits 10, 100, 1000, 10,000. That means the remainder minus 1 plus 1 minus 1 plus 1 for single digits. But here every 3 digits. So that's why the number we have taken to 106659. So take these values here, put plus, put minus here. Divisibility rule for 13. One more thing, the divisibility rule for 13 and divisibility rule for 7 both are same. The reason is 1000 divided by 13, the remainder is minus 1. Next, remainder 10 power 6 divided by 13, the remainder is plus 1. 10 power 9 divided by 13, the remainder is minus 1. 10 power 12 divided by 13, the remainder is plus 1. So minus 1 plus 1 every 3 digits. If I take a number like A, B, C, D, E, F, here put last 3 digits plus, next 3 digits minus. So D, E, F minus A, B, C. If it is divisible by 13, that means whole 16 number divisible by 13. If it is the digit like A, B, C, D, E, F, G, H and I, take last 3 digits together, next 3 digits together, next 3 digits. Here plus sign, minus and plus. G, H, I minus D, E, F plus A, B, C. If this is divisible by 13 means the given value is, that's 9 digit number divisible by 13. Divisibility root for 37. It's very simple. 1000 divided by 37, the remainder is 1. 10 power 6 divided by 37, the remainder is 1. 10 power 9 divided by 37, the remainder is 1. 10 power 12 divided by 37, the remainder is 1. From this you can understand clearly the difference between 7 and 13 and 37. If I give a 6-digit number A, B, C, D, E, F, just to take these 3 digits together, D, E, F and A, B, C. Just add these two, If the sum is divisible by 37 means the total 6 digits should be divisible by 37 also. If I take A, B, C, D, E, F, G, H, I, take these 3 digits, take these 3 digits, take these 3 digits, put plus symbol, plus sign, G, H, I plus D, E, F plus A, B, C. If sum of these values divisible by 37 means the total 9 digits should be divisible by 37. Have you understood the difference between 11, 7, 13 and 37? From that you can derive anything. Divisibility rule for 6 is very simple. That number simultaneously divisible by 2 and 3 both. The divisibility rule for 12 is it's nothing but that the number should be divisible by both 3 and 4. Divisibility rule for 15, the number should be divisible by 3 and 5 both. The number should be divisible by 2 and 7 both. We know the divisibility rule for 2 and 3, 3 and 4, 3 and 5 and 7. There is no unique divisibility rule for 6. The number is divisible by 2 and 3 means that number is divisible by 6. Divisibility rule for 18, the number should be divisible by 2 and 9. The rule for 20, that number should be divisible by 4 and 5. The rule for 10 is very simple. The unit space is 0. I think we discussed all the divisibility rules. I am going to tell you one more method for the divisibility rule for 7. See, if I take 4, 1, 3, we need to check whether it is divisible by 7 or not. Do one thing, just to remove the 3, multiply this value by 2, value 6. What we have to do, remaining 2 digits 41. Subtract this 6 from 41, 35. Is it divisible by 7? Yes. If it is 3-digit number. If it is 4-digit number or 5-digit number, pick one number 3976. First remove the last digit 6. Multiply this value by 2. 6 into 2, 12. Subtract this 12 from remaining 397. 385. Remove the last digit 5. Multiply this value by 2. 10. Subtract this 10 from 38. 28. Is it divisible by 7? Yes. From this you can understand, if the number is A, B, C, D, E, first remove this E. Multiply this value by 2. Then subtract this value A, B, C, D minus 2 times of E. Then again some value will come, P, Q, R, S. For example, again we have to remove this S, multiply this value by 2. Get P, Q, R minus 2S. We'll get 3-digit number X, Y and Z. After getting X, Y, Z, remove this number Z into 2, subtract from X, Y minus 2 Z. We'll get the answer.